Okay, welcome to this tutorial. I'll be solving question 8, 9709, and then that is October, November, then the year 2022. So if you are following what I'm doing, that's what you have to be doing from the start. Okay, I will enlarge it a bit so that you can have the good writing, the visible writing. So this question 8, we are told that in a certain chemical reaction, X grams of a substance, X grams of a substance is increasing, then the differential equation, satisfied, satisfied by x and t, the time in seconds, since the reaction began, is, we have dx over dt equal to kx e to the power of negative 0.1 t, where k is a positive constant. Okay, so it is given that x equal to 20 at the start of the reaction. So part A of this question, solve the differential equation. Obtaining a reaction between x t and k. This is a good question. It came from this topic, that is differential equations, but these ones are ordinal differential equations because we don't have the partial derivatives in them. So we'll not talk about the ODEs and the PDEs because they are not in this syllabus. So we'll start by writing down our differential equation. So these are differential equation, that is dx over dt equal to x, that's kx, then e to the power of negative 0.1 t. So we'll multiply both sides by dt. So you multiply here by dt, then here you multiply by dt. So you realize that the value of dx, it will be kx e to the power of negative 0.1 t dt. Then you integrate on both sides. And before you integrate, ask yourself, do you have the variables of the same type on one side. So for this case, I will not go to differentiation, to integration first. What I'll do, I will collect the terms. So I'll ensure that k is not on this side, so that I can have 1 over x dx equal to k e to the power of negative 0.1 t dt. So you then integrate on both sides. So integration of 1 over x is giving us natural log of x divided by x derivative, which is equal to, for this side we can take the constant, we multiply by integration value of e to the power of negative 0.1 t. So what you can do, we can have e to the power of negative 0.1 t. We are going to do nothing to this power, divide by negative 0.1 t, you differentiate, and then plus constant c to cater for existence of antiderivatives. So from here, what you're going to do, we will have ln natural logarithm of x equal to is negative 10k e to the power of negative 0.1 t, then plus c. We are getting negative 10 because 1 over 0.1 is giving us 10. Because you're having a negative, it has to be negative 10. Now, if you look at this question carefully, there's some more explanation that have been given. So at the time, where the value of x equal to 20, this was at the start of the reaction. And at the start of the reaction, remember, we've not started timing. So the value of t has to be equal to 0. So we'll substitute these two values in this equation to obtain the value of c. So in this case, we are going to have ln 20 equal to negative 10 k e to the power of negative 0.1 times our t value, which is 0, then plus c. So this is giving us, here we are going to have ln 20 equal to e to the power of, this negative 0.1 times 0 is 0, e to the power of 0 is 1. So negative 10 times 1, you're getting negative 10, then negative 10k, then plus c. So our value of c is actually ln 20 plus 10k. So already we have the value of c, so we can substitute to the original equation. We can substitute it to the original equation. So you can have ln x equal to negative 10k e to the power of negative 0.1 t, then plus, we have the value of c, which is ln 20 plus 10k. So that is ln 20 plus 10k. So what do you have to do with this? So you can have ln x equal to, we can group the k's together so that you can have 10k minus 10k e to the power of negative 0.1 t, then plus ln 20. So in this case, you can have ln 20, ln x equal to, we can factor out 10k. So 10k divides 10k once, minus 10k divided 10k 1. So 1 times e to the power of negative 0.1 t is e to the power of negative 0.1 t, then plus ln 20. So already we've solved for that differential equation. I don't think if there is any other thing that you have to do for part A. In case you've not understood, you can consider making the video to be in slow motion, or you can consider asking me the questions so that to clarify the parts that you have not understood. Okay, so I'll go to solve the second part of that equation. So I will write the question here on the board. That's part B. Given that x equal to 40, given that x equal to 40, when t equal to 10. Find the value, find the value of k, find the value of k, and find the value and find the value, find the value, find the value approached by x, find the value approached by x, find the value approached by x as t becomes large. Okay, so this one I'll be made. Okay, I'll need to get the solution that we had in this part. This one here, I will need it being copied over here. So what are you going to have? So we know that our value for ln x, so this is a solution. We know the value of ln x equal to 10k into bracket 1 minus e to the power of negative 0.1 t, then plus ln 20. So this will give us ln 40. This will give us ln 40 equal to 10k into bracket 1 minus e to the power of, so the value of t is equal to 10, so we've been given here e to the power of what? Negative 0.1 times 10, then plus ln 20. So let's get the value of k. So we'll apply the laws of logarithms here. So we'll subtract. So this is ln 40 minus ln 20 equal to 10k into 1 minus e to the power of negative 1. So you can divide both sides by 10 into 1 minus e to the power of negative 1. Then here, 10 into 1 minus e to the power of negative 1. So in this case, we are going to have the value of k. The value of k is ln 40 minus ln 20 minus ln 20. It has to give us the value ln, that is 40 over 20 like that, which is giving us ln 2 over, that's 10 into 1 minus 1 over e. So if you solve for this value in your calculator, you'll get the value of k to be, let me use my calculator to solve for that value of k. Okay, so let me get the value of k. So it will be natural log of 2, natural log of 2 divided by 10 into, that's 1 minus 1 over e, 1 over e to the power of 1. So this is giving me the value of k to be 0.1. 1096, then 5. Okay, let me get it to this far. So already we've solved the first part of this equation, which is find the value of k. Now let's get the value that's approached by x as t becomes very large. So for this case, I'll be forced to go back to the original equation again, which is ln k equal to, not ln k, that's ln x. We're going to have the value of ln x equal to, so that is 10k. This is going to be 10k into bracket 1 minus e to the power of negative 0.20, then plus ln 20. Now, what do we have to do with this? What do we have to do with this? So this one is going to give us, we have to make x the subject of the equation, and the only way we can make x to be the subject of the equation is by having e on both sides. Huh? So we're going to raise everything by e to e, so that you can have x as e to the power of 10k, and of which we have the value of k. So 10k will be 1.096 based on our value here, the value of k here. So 1.0965. So we're going to have 1.0965, and then into brackets 1 minus 1 over e to the power of negative 0.1 t. Then times, we are having plus. So when you're separating them and then you're having a plus, we'll multiply by e to the power of ln 20. So the value of x is giving us, you see guys, when t becomes larger, like for this case, we are having 1 over e to the power of 0.1 t. So when the value of t is very big, the denominator is going to be very big, and this value is going to approach 0. And that's why this part I'm going to substitute it by 0. And this gives us the value 0 e to the power of 1.0965 times e to the power of ln 20, it's giving us 20. So the answer of x will be, use your calculator to get, so this one is going to give you, that is e to the power of 1.0965, then answer times 20 is giving us 59.87. So the accurate value is 59.87, or roughly we can say 59.9. So that is question 8. In the next tutorial, I'm going to be solving question 9. Thank you for watching and listening. Hope you are also following closely with me with your notebook. Thank you.